Let's look at some more methods that we can use when graphing linear equations. So some terminology we'll want is parallel lines versus perpendicular lines. So parallel lines are two lines that never intersect. In fact, it could be more than two, but lines that never intersect. So with that, what it would look like is if this was one of my lines, a parallel line would run parallel to it so that it would never intersect. And how we do that, the key is that they have the same slope. Same slope and different y-intercepts is what it's going to come to as well. So let's go different y-intercepts. Gonna help so that they're landing at different spots, but the same rate of change means they're never going to intersect with each other. Another one is perpendicular lines that intersect at a 90-degree angle. Or a right angle is another way we could describe that. So if I have a line, perpendicular line might look something like this, where we have a nice right angle between them. Now, to do that, it comes down to the slope. The slopes are negative reciprocals of each other. Negative reciprocals. In short, what that means, change the sign and flip. So if you have a slope of 2/3, to make it a negative reciprocal, because it's starting positive, you'd make it negative, and then flip numerator, denominator. That's what the reciprocal part is. Reciprocal means changing the numerator and denominator. If we started with a negative 1/2, our other slope, to make it parallel, we would then have it be positive, and then we'd have 2/1. Or just positive 2 would be a simpler way to write that for the slope. So they have opposite signs. So if one's positive, the other's negative, and then the reciprocals where you switch the numerator and denominator. Okay, so let's look at some different methods here. In fact, actually, since we just talked through those, let's skip over that middle example for a moment so that we can look at how do we write the slope-intercept form of an equation if they're telling us how it's parallel or perpendicular. So we're going through the point 5, -1, and then we're going to be parallel to the line y equals -2/5 x plus 3. So with these, where I want to start is with slope. So because it's parallel, and my original slope is that -2/5, if it's parallel, I keep the slope the same. So for my new line, it's -2/5. So if I'm building together this y equals mx plus b, my new line is going to be y equals -2/5 x plus, and then I don't know what b is yet. But I can solve for b because we have x equals 5 and y equals -1. So what I want to do is plug that into my equation. So I have my slope, and then I want to go through that coordinate as well. So -1 equals -2/5 times x, which we're going to let be 5, plus b, which is -1 equals -2 plus b. Add 2 to both sides, so b is going to be a +1. So my new equation is y equals -2/5 x plus 1. So we set that up so that we had our slope first, and then to make sure we're going through that coordinate 5, -1, we plug it in to solve for b. So let's say we're going through the point 5, -4, and this time we want to be perpendicular to the line y equals 5, 6x minus 5. So our original slope is that slope of 5/6. So if I want my new slope and I want it to be perpendicular, well, my original slope is positive, so my new slope is going to be negative. And then where it's 5/6, it's now going to be 6/5. So again, change the sign and flip. That makes it the negative reciprocal. So we know we have y equals negative 6/5 x plus b. And then to find out what b is, we're going to plug in that coordinate where x is 5, y is negative 4. So negative 4 equals negative 6/5 times 5 plus b, which is negative 4 equals negative 6 plus b. Add 6 to both sides, so b is equal to 2. So we're going to have the line y equals negative 6/5 x plus 2. And if you wanted to, you could check your answers by graphing in Desmos. So if we go to the Desmos graphing calculator, what we could do is graph y equals 5, 6 x minus 5. And then we could also graph what we just found with the negative 6/5 x plus 2. And that should look pretty perpendicular. I like it. Okay, so that's how we could form parallel and perpendicular lines. And then just to go with something we were kind of doing there that we can do here as well that doesn't involve parallel and perpendicular is what if we wanted to form the slope-intercept form of the line of the equation of a line just given two coordinates. So in the previous video, we found the slope doing this, which is where we'll start here as well. So we just need one to be 0.1, 0.2, and with that we'll take the difference in the y values over the difference in the x values. Again, use parentheses to help out with those negatives. So we have 4 plus 1 in the numerator over 2 minus 4, so that's a negative 2. So our slope is a negative 5/2. So we know we have y equals negative 5/2 x plus b. We don't know what b is yet. And to find b, what we need to do is just choose one of these coordinates. Doesn't matter which one, it should work out the same. How about the 2, 4? So I'm going to plug in y equals 4 equals negative 5/2 times 2 plus b. So 4 equals negative 5 plus b. So b is going to be equal to 4 plus 5, which is 9. So our equation is going to be y equals negative 5/2 x plus 9. Again, you could graph it in Desmos and double check that that equation of the line does in fact go through those two coordinates. And let's do one more example here. So through these two coordinates, so let's start with our slope. So difference in y values over difference in x values, again using those parentheses to help out. So 3 plus 1 is 4 over negative 3 plus 2, which would be a negative 1. So we have a slope of negative 4. So I'm getting my structure going with y equals negative 4x plus b. And then to solve for b, we want to plug in one of these coordinates. Doesn't matter which one. How about I'll go with the negative 3, positive 3. So y is positive 3 equals negative 4 times negative 3 plus b. So 3 equals 12 plus b. Subtract 12 from both sides for a negative 9. So y equals negative 4x minus 9. So that's how we can form our slope-intercept form of the equation of the line, either given 2 points or given some information about parallel versus perpendicular. And when they do that, they also have to give us a coordinate to go through as well.